This is section 5.5, the triangle inequality. And this thing I have written right here is actually called the triangle inequality theorem. So this right here is the theorem. And this is really what the whole lesson's about. So let's take a look at it, dissect it just a little bit, and we'll try to understand what it's trying to tell us. So it says the sum of. The sum means you're going to add something together. The sum of what? What are we going to add together? The lengths of any, it's a key word right there, of any two sides of a triangle. Well, here's a triangle right here. And if we add up, let's tell you what, we'll just be generic here and just call it A, B, and C. So it says if we add up the lengths of any two sides of this triangle, what must be true? Okay, the sum must be greater than the length of the third side. So what we're going to do is we're going to take any of these two sides. It doesn't matter which two sides you take. Let's just start with A and B. So if I take A and B and take the sum of A and B, which means I add them together, the sum of A and B must be greater than the length of the third side. So it's going to be greater than the third side. So if I already picked A and B, what's the third side? Well, the third side would be C, since I already picked A and B. Well, it says of any two sides. So I don't have to just pick A plus B. I could pick any of the two sides. So let's pick A plus C. And if I go A plus C, that must be greater than the other side, or the third side. So if A and C was already picked and I added those together, what's the third side? That would be B. So if I add these two together, it must be bigger, not equal to, must be greater than the third side. What's the two that we haven't picked yet? Well, B and C we haven't picked. So let's go B plus C. If I add up B, side B and side C, and I add them together, you must come up with a number that's going to be bigger than the third side, and the third side is A. So that's basically what this theorem says. All right there. That's kind of what it's telling you. Let's do this. Let's put some numbers in here. Hopefully it makes a little bit more sense when you see it with numbers. All right, I'll pick some numbers that actually work. Let's pick 3. We'll pick 5 right here, and we'll pick 7. All right. So what we have to do, and this is the question they're going to ask you. They actually might not even give you a triangle itself. They may, but I think they have a whole bunch of problems where they're going to give you 3 sides, like 3, 5, and 7. And the question is, tell whether these 3 sides form a triangle. So how do I know if they form a triangle? Well, I should be able to add up any of the 2 sides, and it must be greater than the third side. So let's add 3 of them together. Let's just take the 3 and the 5. We'll do this right here. So 3 plus 5, well, that equals 8. Is 8 greater than the third side, which is 7? Yep. So far, so good. Let's try some other ones. We tried 3 and 5. Let's try 3 and 7. Let's add those together. So 3 plus 7 is 10. And so we use 3 and 7. That must be bigger than the third side. Is 10 bigger than 5? Yep, absolutely. What else didn't we pick? 5 and 7. Let's add those together. So 5 plus 7 is 12. And so 5 and 7 is 12. Is that bigger than the third side? 3? Yep, sure is. So if all 3 of those things are true, then this is a triangle. And that's all they're asking you. They're asking you, can you form a triangle with these 3 sides right here? And your answer would be yes. You can form a triangle with those 3 sides. Let me give you a little shortcut though. Okay, it's actually a little bit easier if, let's take a look at this. If you take like the largest side and add it, you know it's going to be, right, if you take the largest side right here, like the 7, okay, and you add it to either one of the sides, you know that it has to be bigger than one of those other sides because you already picked the biggest side, didn't you? And you picked the biggest side right here. What's the only way that it probably wouldn't work, or there's a chance that it wouldn't work? If you took the 2 shorter ones. So watch. What I'm going to do, instead of going through all 3 of these, you don't have to go through all 3 of them. I'll give you a little shortcut. The shortcut is take the 2 shorter ones, take the 2 shorter sides, add them together, and then compare it to the third side. If it's still bigger than the third side, yes, it's a triangle. If it's not a triangle. You don't even have to waste your time going through these 2 steps. So I would just stick with this step right here, take the 2 shorter ones, add them together. The 2 shorter ones have to be bigger than the third side. And that makes things a little bit easier for you. I hope that made sense. Let's switch over to this other program, and hopefully I'll show you why this works. Okay, I mean, it's easy to do the problems. These problems are actually very simple and very quick to do, but it's nice to have an understanding of and to see it visually why this actually works. All right, I've set this thing up where these things are called sliders, and this is kind of cool. Watch this. When I take this right here and I move it over, see it changes those numbers, but it doesn't just change those numbers. What did it do to my graph? It actually made that red one. See how they're color coordinated? It made that red one longer. It made it 5. Like all the way here, the length of that red one is 1. They're all of them are 1. And I can take that one, make it bigger. I can take the blue one, make it bigger, and I can take the green one and make that bigger, which is kind of cool. So what I want to do, let's go start off with 1, 1, and 1. Let's try a couple examples of some sides that make up a triangle and sides that don't make up a triangle. So what did we use before? We used, I can't even remember. We just did it. 3, 5, and 7. Okay, so let's go 3, 5, and 7. So let's make the green one 3. Let's make the blue one. It doesn't really matter. Doesn't make any difference. Let's go 3, 5, and let's go 7 right there. So those are the lengths of those sides. What I want to do is I want to move them around, and you'll see this in a second. I can move these around and not change the length of the side and try to form a triangle. So let's give it a shot. So let's take this end point, move it like this, and I want to make a triangle out of this. So all I got to do is connect those two up, right? Let's make this a little bit bigger so we can see it. And let's scooch it up. There we go. All right, and let's see if we can make a triangle out of it. And it's looking like, yeah, we're going to be able to do it. And match it up. That's pretty close. There we go. We got a triangle. So there's our triangle with sides 3. This green one is 3, the blue one is 5, and the red one is 7. All right, that was good enough. Let's try, let's go back like this. Oh my. Let's put these a little bit straighter, and then we can see what's going on here. And let's just scooch this over a little bit. Oops, grab the right thing. All right, there we go. Sorry about that. All right, now let's try some other sides. Let's try, what did we try? 3, 5, and 7. Oh, by the way, if I went 3, 5, and 7, I should have done this. Watch. We did it earlier, and I might even change this. Let's make this a little smaller so I can see the end points. There we go. So there's, I made that 7 this time, and I just to show you, it doesn't matter what ones you make, 3, 5, and 7, you're still going to be able to get a triangle out of it. And I just got to play around with it a little bit until that's pretty close. We've got a triangle. So look at my numbers. I got 3, 5, and 7. So I take the two shorter ones, 3 and 5. That's 8, and it's bigger than 7. So yes, I can make a triangle. We already worked with those numbers earlier. I just wanted to make sure that you understood that. All right, so let's put this back here, and let's put this back here. Let's try another one that works, okay? And then we'll try one that doesn't work. So let's just change the value of that. Let's make that 6. Let's make this a little bit smaller. And let's see. Let's say that this, and we'll make this like a 1. Let's do this. Yeah, we'll do like that. That's good. Okay, so 3, 4, and 6. Let's see if that works. Well, you can look at it without looking at the graph and figure out if this is a triangle or not. That's what, when I say if it works, I'm trying to figure out, does it make a triangle? Well, I'll take the two shorter sides, 3 and 4. 3 and 4 is 7. Is 7 bigger than 6? Yes, it is. So the sum has to be bigger than the third side. So let's see if that makes a triangle. So we'll twist this around like this, twist this around like that, and we'll move that around. And then we gotta, sometimes when these, let's blow this up a little bit. Sometimes when they get a little close, it's hard to grab them. And that's pretty close, okay? There's a triangle, all right? 3, 4, and 6. Yep, we can make a triangle out of that. Let's make this smaller so I can stretch them out again. Let's do this. Now, let's try one that actually doesn't work. Let's try, well, let's see. What if I made this a 2? Will that work? Okay. There's the two smaller sides, 2 and 3. If you add them up, it's 5. Is 5 greater than 6? Nope. Last time I checked, it wasn't. So let's see if we can make the triangle from this. Let's see if that theorem actually is telling us the truth or not. So I would have to bring this over here like this. Bring this blue one over. A little bit of a problem. Are you going to get them to match up? No matter where I put this thing, no matter where I put this thing, guess what? They're not going to meet. Look, I can take this out as far as I possibly can right here. take that out. See, that's as close as they could possibly get together. But are they ever going to touch? They will never, ever touch each other. So that will never, ever be a triangle. And how do we know that? We took the two shorter sides and we added them up, and the two shorter ones is not bigger than the third side. So if it's not bigger, then it's not a triangle. That's all you got to do. All right, you don't have to do all this stuff down here. This is just so you can visually see what's going on, but it kind of shows why this is not a triangle. All right, I don't know. Let's do this one. Let's make E a little bit bigger. We'll go obtuse. Okay, can you have a triangle like this? Here we go. This is a good one. I got 3, 6, and 9. Can you make a triangle out of that? Well, what do? What's the test? You take the two shorter ones, that's 6 and 3. You add them up, that's 9. Is 9 greater than the third side, which is 9? Is 9 bigger than 9? No, it's not bigger than 9. So look, can I make a triangle? You're like, yeah, that makes a triangle. No, it doesn't really. Let's blow this up a little bit, okay? So there's no way, watch, there's no way I can get this. And you're like, well, what if I went way down here like this? Well, watch what happens. Actually, let me scooch it out so it looks more. See, it kind of looks like they touch right there, but they're not going to touch, because if you think about it, watch. If I could take that blue one, if I can grab these now. Oops, wrong tool. Let's try to grab it. When they're so close together, it's hard to just grab one of them. Let's see which one I can grab. Let's take this one and make it just straight across. Watch this one. If this green one is 9, right? And if I went all the way down to there, that's where it's going to hit. As soon as I go up like this, right, and I bring this up, it looks like they are right on top of each other, but there's actually going to be a little bit of a gap. Because if they meet exactly right here, and if I bring it up a little bit, and I bring this up, it looks like they touch, but it's not going to be dead on perfect. Okay, it's not going to be a perfect fit. Let's make this a little bit. I'm going to blow this up a lot. All right, so if I brought this up, do you see how it's not a perfect fit? As soon as I bring it up like this, there's no way that they're going to fit. The only time that they fit is if they're along a straight line. And can you have a triangle if they fit along a straight line? No, of course not, because you need some kind of angle in here between the red one and the blue one. All right, that's a little over explanation, and I tend to do that sometimes. Sorry about that. Let's go back to the other screen, and let's talk about one more thing. Okay, here's a question that they're going to ask. They're going to ask something like this. Not something like this, exactly this. Got this right from the book. It says, find the range. All right, there's a new word for us. Find the range for the measure of the third side of a triangle given the measures of two sides. So I'm given the measures of two sides of a triangle. And the first problem I'm looking at is, in fact, this is right. Is this the one from your lesson? I think it is. All right, so I'm doing one for you. This is number 12, actually. I'll do this one for you, then you can do the rest. All right, so it says 4 and 8. So that's what's given. They're giving you the two sides of a triangle. Well, yeah, they're given two sides of a triangle. So what I want to do is I want to find the range, which means what are the values that the third side right here, what are the values that that third side could actually be? All right, between what and what. That's what it means by find the range. Okay, but you know, it's got to be bigger than this and it's got to be less than this. That's the range of the measures of the third side of the triangle. So here's the two sides. Okay, I made one double the other one, so we'll call this one 4, and we'll call this one right here, we'll call that one 8. So if I wanted to make a triangle out of this, watch, let's put this right up against it. I'm going to hit my rotate tool, so this is going to rotate like this. All right, let's think about that third side right there. Now, if I went all the way like this, what would that third side actually be? So if that is 4 and that length right there is 8, what is it from here all the way to here? Well, that would be 12. But can I have a triangle with a side of 12, with a length of 12? No, I couldn't, because if I did, let's see if I can do this. If I did, it would just be a straight line across. Okay, I have all straight lines across. There's no bend of that, right? What happens though, watch, let's try this again. What happens if I bend that one just a little bit? What's going to happen? And let's grab this. What's going to happen to that blue one? it actually, let's see if I can, did I click it? I think I did. Watch this. If I go like this, now it kind of looks, but look, it looks a little bit longer, doesn't it, than that yellow right there. All right. And if I bend it, watch this. If I bend this some more, let's rotate this up. Look what's going to happen. Okay. It's a little more obvious there. That length right there, that 12, there's no way it can be 12. So what does it have to be? As this bends more and more and more, what happens to that third side right there? Well, it's not 12, it's going to be less than 12. So our value, our third side, has to be less than 12. So x is our third side, and it has to be less than 12. All right. So our third side has to be, if you add up the two lengths, the third side has to be smaller, less than the sum of those two sides. Okay. And that kind of makes sense from what we did before. But watch what happens to this. We're almost done here. If I take this and bend it all the way over here. Now watch what happens to that third side. That third side gets really, really small now. Okay. In fact, might be easier just to draw it from here to here. See, that's way less now. See, it's a triangle, but what happened to that third side, that blue one right there? It was a little bit smaller than 12, but watch what happens. As I take this, how small can that blue one actually get? That's what I want to see. How small can that third side actually get? Oops, I did the wrong thing. I gotta click on this and then do this. Okay, now watch. It comes all the way to here. Remember, that red one was 8, and this yellow one right here is 4. So how much is it from here to here? Now watch, if I take this, and I could take it way down to here, what's happening to that blue one? Remember, it started off at 12, but it's getting closer and closer to how much? The yellow one is 4, the red one is 8. So what's the blue one getting close to? It's blue one's getting close to 4, 8 minus 4. So the blue one, it can't be equal to 4, because if it was equal to 4, it would just lie on that straight line. It's just got to be a little bit bigger. See, as soon as this goes up just a little bit, it's going to be just a little bit bigger than 4 in order to make a triangle. So with all that said, what are we saying? We're saying that x has to be less than the sum, all right, I'll put that, of the two sides, and x has to be greater than the difference of the two sides. I'll just put DIFF for difference. What does difference mean? Difference means you subtract. Sum means you add. So basically, this is what it means. If I'm given two sides of a triangle, what is the range of the measures? This is what I do. X represents the range. It's in between, right? So x has to be less than this number, and x has to be greater than this number. So how do you find the smaller of the two? You just subtract. This is how easy it is. I mean, doing this math is just so super easy. The explanation's a little difficult, but the actually doing it is really, really easy. So x has to be bigger than 4, and x has to be less than, add them up, and it's 12, and there you go. So x has to be between 4 and 12, and that's how you find the range of the measures of the third side of the triangle. So again, what do? Just take these two numbers, you add them up, you stick them right here. Then you subtract them, you stick them right here, put an x between them, and this is how you set it up. Just follow how I set it up. This means x is less than 12, and it means x is greater. If I read it from right to left, x is greater than 4. Okay, or 4 is less than x. So x is somewhere in between. So what could my possible value be for that blue? Well, any number between 4 and 12. Okay, I could have picked 5. Would 5 work? Sure it would, because look, 4, 5, and 8. 4 plus 5 is 9, and 9's bigger than 8. Yep, that works. Try another number between 4 and 12. I don't know, 10. All right, does 10 work? Well, 4 and 10 and 12. Can I make a triangle out of that? Sure, take the two shorter ones. 4 and 10, that's 14. Is 14 bigger than 12? Yep. You can pick any number in between those two, and it'll work. Let's try something. Let's try a number that's not in between 4 and 12. Let's try 1, all right? So can you have a triangle with sides 1, 4, and 12? Well, take the two shorter ones. 1 plus 4 is 5. Is 5 bigger than, oh, I'm sorry. I don't want to pick 12. Sorry about that. It's 8. Okay, I'm picking 4 and 8. So if I say 1 plus 4 is 5, 5 is not bigger than 8. So can you make a triangle with sides 1, 4, and 8? No, you can't. All right, I hope that makes a little bit of sense, and that's pretty much it. Actually doing this homework should be very simple. It's a matter of understanding why this stuff is true is what's a little bit more difficult. So good luck on this homework.